Suppose you're asked to sketch this line. Oh. Would you be able to sketch it? Do you know what it would look like? Remember, previously we had looked at a line y equals a number, and we said that as long as the y value is that number on the line, it doesn't matter what the x value is. We just draw the line and it satisfies y equals the number. For example, we looked at y equals 2. This is the line y equals 2 because at every point y is 2. Now, remember that this is our y-axis and this is our x-axis. Don't forget that. Now, if you should sketch this line, x equals 3, it would look like this. Notice at this point x is 3, x is equal to 3 here. Y is 0 and x is 3. What are the coordinates of this point? Y is 1 and x is 3. So x is 3, y is 1. This satisfies this line, this equation. At this point, x is 3, y is 2. What's important here is that x is 3. So this point satisfies this equation. When you come down here, x is -1, what is y? Y is 3. Y is -1, what is x? X is 3. Down here, when y is -2, what is x? X is 3. So all of these points satisfy. We could even go halfway and say this is -1.5. Y is -1.5. X is 3. -half is y. 3 is x. Right here, x is a half. X is 3 and y is a half. Right here, y is a quarter here, but x is 3. So no matter what you do, the line will be like this. Right? This is the line x equals 3. So the line x equals 4 would be this. The line x equals 7 would be this. And so on and so forth. Now, what is the gradient of this line and the y-intercept? Well, you can see that no matter how much you go up or down, it will not cut the y-axis. So the gradient of the y-intercept doesn't exist. It doesn't have a y-intercept. Alright? The gradient is what? Let's try and figure out what the gradient is. Let's erase this and we try and figure out what the gradient of this is. Suppose we say we use our x1 and y1 formula. At this point, this is point 1. At point 1, we have our x1 and our y1. What is our x1 here? X1 is 3 right here. Y1 is also 3. Okay, no problem. What about down here? This is point 2. So we're going to have our x2 and our y2. Let's put in the values for our x2 and y2. At this point right here, our x2, it lines up with the same 3. So if it's 3, y2 is -2. Now, suppose we try to find the gradient equals y2 minus y1 over x2 minus x1. y2 is -2 minus y1 is 3, good, over x2 is 3 minus x1 is 3. What will you end up with? 5 over 0. But then we looked at this in a different topic and saw that a number divided by 0 is meaningless. It is undefined. You cannot define that value. So you can say the gradient is undefined, right? You can think of this as having infinite gradient. So in this case, the gradient is undefined. But just as a quick reminder as to why this wouldn't work out, is that an example, you know that speed or velocity equal distance over time. If you travel 30 kilometers and the time you took to travel 30 kilometers was 0 seconds. Now, how could that happen? Is that possible? The thing is, not even light, the speed of light can do that. And if you do physics, you know that theoretically and practically, you cannot travel faster than the speed of light. It would take infinite energy. It is impossible to travel 30 kilometers in 0 seconds, right? Can't do that. So it's meaningless. Cannot work. All right. So you do not really have you don't have a y-intercept, neither do you have a gradient, a defined gradient for this. But it is in the form, the general form, x equal a. So if you're asked to draw or to sketch the line x equal the number, it's a vertical line, right? It goes up and down and passes through that number on the x axis.